In this lesson, we're going to define some trig pieces that we're going to use in future sections. Just some kind of information that you're going to continuously use throughout a trig class. And they're kind of categorized a little bit. First is reciprocals, that if you have a sine of theta, it's equivalent to 1 over cosecant. Remember, these are reciprocals of each other, so they're equal to 1 over each other. Most likely what's actually going to happen is if you ever have a fraction and you have a trig value in the denominator, you can bring it up to the numerator and turn it into its reciprocal. So if you have 1 over secant, you can turn it into a cosine. If you have a 1 over cotangent, you can turn it over a tangent, and so on and so on. So a 1 over sine can be replaced with a cosecant. So that's totally something that you're not breaking any math rules. That's fair game. There's a whole lot of manipulation that you'll be able to do in the trig world. Another piece that will become valuable is the fact that when you multiply reciprocals together, you get 1. Well, you can show that with an easy algebra one too, is if you take 2/3 and multiply it by its reciprocal, everything cancels. So 2's cancel, 3's cancel, and everything just becomes 1. So no different with a trig function. And then you have tangent is not only equivalent to 1 over cotangent, but it's more commonly replaced with sine over cosine. And it's like, well, where does that even come from? So we're going to show not just like, hey, this is it, but where does that come from? And then how on earth does sine squared plus cosine squared equal 1? And then what the heck are these? We're going to show real quick kind of where these pieces come from rather than just they are what they are. So tangent is equal to a sine over a cosine. Where does that come from? So we're going to start off by drawing a circle. And in the past, we've done this where we take a point, put it on the circle, make ourselves a triangle out of this, and then we have a horizontal distance and we have a vertical distance. So x is our horizontal distance based on our coordinate. Y is our vertical distance based on our coordinate. And in the past, this was a radius. This time, though, we're going to be talking about the unit circle. So on a unit circle, that locks our radius at 1. So we're not talking about bigger or smaller circles. We're just talking about a basic circle with a radius of 1. So with that, if we do tangent of this, or if we do sine of this, cosine of this, so if you were to do sine of theta, our angle is going to be down in the corner with the x-axis. So sine of theta is going to be opposite over hypotenuse, which is just y, because we really don't need to write it over 1. Cosine of theta is going to be adjacent over hypotenuse, so x, and then tangent is going to be opposite over adjacent, so y over x. All right, so how does that tie in with that? Well, things are interchangeable. So sine is equivalent to y. So if you have a y value, you can also replace it with a sine. And x can be replaced with cosine, which really leads us to exactly right here. Y is a sine value, and x is a cosine value. So where does tangent equal sine over cosine? It's because tangent equals y over x, and y is sine, and x is cosine. So tangent also equals sine over cosine. So that's where this piece comes from. This piece is just going to come from the fact that cotangent is the reciprocal of tangent. So if you know tangent is sine over cosine, then you just do the reciprocal to get cotangent. So where does this come from? Well, this comes from the fact that you're looking at a circle, and the equation of a circle with a radius of 1 centered at 0 is x squared plus y squared equaling 1. X is cosine, so that's cosine squared plus cosine of theta squared plus your y value is sine squared theta equaling 1. So since it's addition, I could rewrite it into that. So that's where that one comes from. That one actually just comes from the fact that it's an equation of a circle. Sub out your x's and y's. So where does a tangent, where does a secant come from? It actually all comes from this. This ends up being a pretty big one. You can manipulate this into this. So to do that, if we wanted a tangent, so let me rearrange this, because surprisingly it's a little nicer if it's in this order. So if I want a tangent from a sine, I can make that happen by essentially creating that fraction. So if I divide this by cosine squared, I have to divide everything by cosine squared. So as long as I do everything, divide everything, I'm keeping an equivalent statement. Well, sine squared over cosine squared is tangent squared. And then the 1 comes from these two. And then the secant comes from this idea back up here. If we have a denominator of a cosine, we can bring it up. We have a denominator of a cosine, we can bring it up, and it turns into secant. And then how do we go about creating this one? We take our same sine squared theta plus cosine squared theta equaling 1. And I want to create a 1 out of the first term. I want to create a cotangent. I want to create a cosecant. Well, I divide everything by sine squared. And then that becomes 1. That becomes 1. Plus cosine over sine is cotangent. So cotangent squared. And then this would be cosecant squared. So this is the big one. And then you can manipulate it to create anything. So that's going to be happening later in a trig class. You're going to do all sorts of manipulations to go from something to something else. But these are some of your main ones that you're going to definitely be using frequently. So that was an introduction to some trig definitions.